My name is Tongxin. I just come from Northeast Forest University. So I'll continue my presentations through the following four perspective. So although not majority of people not familiar with my research area, so I will cost a few minutes to introduce my research background. So this is a report from the IPCC released from the year of the 2018 issue of the South Korea. So although every time the IPCC reports raise a great controversial, but this still from another perspective remind us that global is really warming. So this report attributes many caused by the carbon dioxide and the soil respiration as a major flux of carbon flux to atmosphere. So we know that the soil respiration is the primary pathway by which carbon dioxide is fixed by the plants and the return to the atmosphere, which is a key process of carbon cycle in terrestrial ecosystem, which account for the 2 to 3 of the terrestrial ecosystem. So this is the paper that published by the Bond and Lamberti during the year 2018. It indicates that during the last 20 years that the ratio of the heterotrophic respiration to total soil respiration is significantly increasing. And I mentioned that the important information that soil respiration is mainly from two parts. One part is the autotrophic respiration, which from the roots. Another is that heterotrophic respiration, which come from the microbees activities. So during the classic model, that NEP is equal to the MPP minus the heterotrophic respiration. So with the increasing of this ratio, that means that if this ratio continue increasing, that means that our forest ecosystem will lose a lot of the carbon. This may make our forest ecosystem loss of balance. So global climate change model predicts that the most rapid warming in boreal and Arctic will further increase the flare severity and frequency. China is not exception. That known as China's the boreal forest mainly in the Great Xinjiang Mountain area. So it's also the flare occurrence area. So maybe the majority of people not know that, but maybe some people know that the black dragon flare occurred in the year of the 2083, 87 that occurred that in this area, what we call about the black dragon fire. It's really big. The typical forest is the Dahurian Larch forest, which accounts for about approximately 80% of our research area. It's similar to the Japan in Canada, and it's also have many island forests and swarm and peatlands. So I need to mention that it's not only the boreal forest, it's also a global boreal south edge, which is very sensitive to climate change, and this area is a transition zone from boreal forest to the temperate forest. So we need to continue monitoring the soil carbon in this area. This is a global climate change. We know that, so we need to pay much attention to this work. So we have done many research about this area that we measurement the soil respiration in growing season after flare disturbance. Almost after 20 years, the flare disturbance declined about approximately 25%. And the temperature is the dominant factor, but rather the water content is the dominant abiotic factor in this area. And we also measurement the non-growth season. We found that during the non-growth season, the soil respiration account for approximately 4% of the annual soil respiration. We also found that soil cover directly increased the soil respiration of this area through the significantly increased the soil temperature. So we also do some research about the flare disturbance on the effect of soil respiration heterogeneity, spatial heterogeneity. We found that after flare disturbance, the spatial heterogeneity increasing. So, but recently, several research that after flare disturbance, the components of soil respiration have many different response. So several studies have also indicated that the flare disturbance on the microbe activity and plant roots and directly influenced by the changing of the soil pH value, so nutrients availability and substrate quality, which will lead to which will relate to some microorganism and flare roots. So we want to know the mechanism behind flare disturbance on the soil components. So we will continue to doing this kind of research. So the object of our study is to determine how fair disturbance of how soil respiration components respond to fair disturbance in a boreal forest of China. And second is elucidates the abiotic and biotic driving factor of soil respiration after fair disturbance. And our hypothesis that based on our previous research that there may be different response to soil respiration components to fair disturbance, which will lead to the increasing of the RH to the soil heterotrophic respiration to total soil respiration. And the fair will cause a shift of dominant abiotic factor and biotic factor change after fair disturbance. So I will introduce the research method that research area that a fair occurring in year 2014 is a high severity fair disturbance, and we choose the burn area as a research area, and we choose the nearby and burn area as our control plots. So this is our timing classification. We measure the whole year of the soil respiration, and according to the air temperature and soil temperature, we classify the whole year as a growing season, non-growing season, and the dark green area is the spring, freeze, and soft cycle period. So after basic information that after fair disturbance, the canopy density and the organic matter layer depth and bulk density all in decreasing. And then we're using the transient method and the RA6400 to measurement soil respiration and its components. Oh, I need to see that it's really tough work doing this kind of research in the winter in the non-growing season. So we need to thank all the students who participated in this work. So let me introduce our results. That's the first one, that the effect of fair disturbance on the abiotic and biotic factors. So we're finding that after fair disturbance, the soil temperature, the ammonia nitrification, ammonia, nitrogen, and the microbial biomass carbon and pH value are increasing, but the water content decreasing and the soil organic carbon decreasing. And surprisingly, we found that nitrate and nitrogen no change, and ferrous biomass no significant change. But we found that during the growing season, the ferrous biomass decreasing, significant decreasing. So about the soil respiratory components, we found that after fair disturbance, the total soil respiration and the soil autotrophic respiration decreased approximately 17% and 55% respectively. But surprisingly, we found that the soil heterotrophic respiration increased approximately 24%. And this result driving another interesting finding that the ratio of the soil heterotrophic respiration to total soil respiration significantly increasing during the whole year of our research period. And we know that this will lead to a lot of carbon loss potentially. So this means that we need to carry on a much more active forest management activity after fair disturbance, such as the afforestation. And we also want to know the relationship between the soil respiration and the soil properties. We found that consistent our previous finding that soil temperature is still the dominant factor of the abiotic factor influence the soil respiration and its components, but no significant relationship with the soil water content of the soil respiratory components. But another exception is that during the burn stand, we found that the soil heterotrophic respiration significantly correlated with the soil water content. I think that it's attributed by the fair disturbance or redistributed water content lead to the different response. And we also test the other correlation with other factor of the soil respiration is the components. And then we choose the significant factor introduced to our structure equation model. And A figure is the amber area model, and the B is the burn area model. We found that in the A figure that the temperature is still the dominant abiotic factor influence the soil respiration, and the soil organic carbon have a positive correlation with the ferrous, promotes the ferrous biomass, and the ferrous biomass is the dominant factor, abiotic factor driving the soil respiration in the burn area. And in the burn area, the soil temperature is still the dominant factor of the abiotic factor influence soil respiration. This is a little bit not consistent with our second hypothesis. And we found that the temperature have a negative effect on the soil fan roots biomass. That means that after the fair disturbance, the high temperature have not a positive effect on the fan roots and not positive for the growth of the fan roots. And we found that ammonification, ammonia nitrogen have significant correlation with the fan roots and the microbiomes, and promotes the microbees activity and lead to contribute to the dominant factor of the soil respiration after fair disturbance. So we can find the interesting finding that after fair disturbance, the biotic factor have changed. That may reveal the mechanism behind the fair disturbance. And we also use the annual soil temperature to evaluate the whole annual carbon efflux using the following models. And we choose the best model according to the R-square result and archive key value. And we found that during our result, no matter in growing season, non-growing season, spring, FTC period, and annual, the hydrotrophic respiration almost all increasing, all significant increasing. And we found that surprising result is that spring FTC period, no matter the hydrotrophic and autotrophic are increasing, and the fair promotes the free and soft cycle periods, which means that the fair effect on this area and the effect on the spring free and soft cycle period, this result should, and related to carbon cycle should not be ignored. I think we need to continue to do this further work about this. I need to reach some conclusion about the research that our finding demonstrates that the great discrepancy in response to soil respiration components to fair disturbance. Fair driving the ratio of hydrotrophic respiration to total soil respiration significantly increasing during the boreal forest of China. And second, that temperature is still the abiotic factor dominant soil respiration in no matter in burn area and unburn area, whereas the microbiomes carbon, but not fan roots biomass, was the dominant biotic factor driving the soil respiration after the fair disturbance in boreal forest. The third one, that forest fire will potentially cause considerably loss of the soil carbon in boreal forest ecosystem of China, which suggests that a proactive measurement of the forest regeneration should be carried out after fair disturbance. So I still want to give you some outlook our further research that we just go back this slide that we found that a black carbon maybe have other name, paranonic carbon, or the biochar. This is quite similar name, quite similar. That a byproduct of the forest is very important. Usually we ignore the biochar, or black carbon effect on the boreal forest ecosystem. Recently, research found that effect of biochar will affect on the carbon and nitrogen flux in boreal forest. So during our plot, we also found it's quite similar that we found that still some black carbon and they have very thick layer of the black carbon. So we do this kind of treatment that we the first remove the surface layer and have the aiding the black carbon low treatment of the 5 kilogram per hectare, or the high treatment of 10 kilogram per hectare. So we want to quantify the effect of the fair disturbance and the black carbon effect, all the interaction between the fair disturbance and the black carbon effect on the soil respiration. So we want to quantify the mechanism behind it and how that precisely to know the results. So this is our next step work. The first step, we want to know the properties of the black carbon. This is the first step, and more importantly, we want to know that how does the black carbon affect on the biotic process, such as later decomposition, the fan roots turnover, the soil microbial community structure, and the rhizospheric effect and the vascular mycorrhiza and anomycorrhiza and soil animal change after the aiding of the black carbon after fire disturbance. So we will maybe we will continue this work. Maybe we will share the results of this work as the next annual meeting of the Cold Forest. I hope so. I hope so.
Oh, sorry.
Yeah.
Go ahead.
Yeah, I still want to introduce our research group. Is that our team leader is Sunong, our dean, and maybe I have contact Ralph several times. That the next meeting will be held in Harbin, China. So we very appreciative for giving such an opportunity and hoping that you can achieve this meeting. And we welcome to China and Harbin and our university. So we also want to thank our research group for supporting our research. So if you are interested about research, please contact with us. We can further to finding some interesting scientific problems, and we will pushing on to paving the way to further explore our research. Thank you, family. Thank you for your attention. Thank you.
Thank you very much, Tongxin. 谢谢你, Tongxin. We have 2 minutes of questions, so please go ahead. Either use the chat or raise your hand. Thank you.
So I will stop my share. Okay, the first.
Are there any questions for Tongxin?
Yeah, several questions.
But
go ahead.
No, go ahead, Raphael.
Yeah, I can hear.
Minani, do you have a question, or otherwise I can ask a quick one?
No, I had, because I partly work also in the Amazon where there is a lot of black carbon and there are a lot of specialist species. So it's not only a change in activities that we see, but also a change in terms of species composition. Is it something, for example, when you see there is a lot more microbes and microbial life, do you also follow the changes in biodiversity and linked with these changes in respiration?
Yeah. I have ever do this kind of research. That's that's really effect on the biodiversity. Yes. I cannot hear your question. Could you repeat one more time?
No, I was wondering whether, because you studied the activities, and that's really interesting, and that's true that also in the Amazon, for example, on black carbon, we see a lot more microbial and especially bacterial activity. And it's also associated with the selection of specialist species. So I was wondering whether there were some parallels also with kind of specialist species appearing on your site where you have a lot of fire. Or perhaps
yes, I think we just start this research this year, so we will further to continue the research to determine how does the black carbon affect on the species of the microbes. We will continue to work. Maybe we'll share this work as the next year meeting of this conference. I hope so.
Thanks.